more or less. Are you ready to start, or we wait? We'll start exactly on time. 4 minutes, or do you want to start, or I think most of the people are here, so we will get it going. Is that okay? Yeah, so thanks all for joining during lunch. So my name is Wim Hendricks, and I will be co-presenting with Brian and Reza, who will do also a piece of the talk. So the goal of this presentation is mainly to talk about 5G and the impact on the networking side. So 5G is much bigger than what we are going to talk about in general, but we try to focus on this presentation on mainly the impact on the networking side of what 5G is about, and that's going to be the main focus of the talk, okay? Just to introduce 5G, because 5G means many things to many people, and typically the way I try to explain it, if you try to summarize it, you see that it can be summarized in like 3 big buckets, right? One is actually getting more bandwidth to end subscribers such that we improve the bandwidth, get more speeds, make sure that video is consumed much faster onto the network. The second thing is kind of more connectivity, so more IoT, more devices which are getting connected to the network. And the third elephant in the room is kind of Industry 4.0, as we call it, which is introducing new concepts like very low latency, ultra reliability, and so on and so forth. And that has a rather dramatic impact on how networks will be built going forward, okay? Now, if you then look, if these are like applications or like use cases which are all going to become relevant for a set of people, the second big aspect what we see is that the way we are implementing some of those applications or devices which are actually consuming or actually delivering some of these services, that is also a big shift, right? So we used to connect things via physical devices. They were all set together. It's an appliance all in one. If you look going forward on what's happening with NFV and virtualization, you see that we started introducing quite a lot of virtual machines, but in the meantime, we talk about microservices, we talk about containers, but we already, some people are talking about functions, so it's no longer something which you can physically touch, right? So as a result, you see that in order to define and build the network around these things, you actually have a very heterogeneous environment to deal with, right? So that's the second big thing to take into account. And then, of course, people want to introduce things faster, wants to make sure that things happen much more quickly, that it's much more agile, and that we come into the realm of programmability, automation, intent-based networking, and so on and so forth. So we want to make sure that some of these services get more delivered more quickly, like basically the big guys or the big web guys are doing, is they introduce services much more quickly and much more faster into the network, and make sure that things get consumed way faster than we used to see going forward, right? If you put this all together and trying to build, let's say, a framework or an architecture around this, it's kind of a big thing, right? Because you see that there is lots of changes, lots of things are happening. And what we try to do within Nokia is say, okay, if you look at all of this environment, how do we deal with all of that, right? And I think this is where IETF played. I think they built an important concept from the early days. And if you look at it, we actually, in order to build like a network infrastructure to support all of this, we believe there is 2 key principles which are important to keep in the back of our mind. Switch off the Wi-Fi. Is that in order to provision these things in that heterogeneous space, it's important to basically provision it at the edge and leave the core or the elements in the middle untouched, right? So we always say, okay, introduce a service at the edge and try to make sure that the elements in the middle are not touched when you provision new services, right? And as a result, you actually get a more easy way of introducing things. The second important thing is actually, it's decoupling service from transport, because that allows us to actually focus on a certain set of use cases in order to not boil the ocean and try to make sure that we actually do things in a very easy and more agile way. Now, if we, and in this presentation, when I talk about an edge, I talk about mainly the data plane, or to a certain extent, or a control plane of a router or a forwarding device, right? So sometimes in 5G, we talk about far edge, which is a cloud infrastructure, or an edge, which is a cloud infrastructure. Here, I'm talking about an edge, which is mainly the data plane or the control plane aspect of the thing which is delivering the network, right? And as I said from the beginning, is that you see that those workloads are evolving, so we see containerization and stuff like that, so you see that the edge implementation in a 5G or in a network going forward is not something which you can touch necessarily, right? So we have, here are some examples like physical devices. We used to have edge routers, right, which were routers built in chassis or in pizza boxes. You see going forward that some of these implementations would happen on a data center switch, which is acting as a top of rack type of thing, or you actually do it on a peering type of device. But an edge can also be like a virtual thing, or in a microservices architecture, it can be like a user plane function sitting on a server. It can be a virtual switch implemented on a server, or it can actually also be like a virtual switch implemented on a NIC going forward. So you see that the environment which we are having available to us in order to connect all of these things together is a big, there's quite a lot of variety, right? The second big question is, and here is probably, oh, no, there is no automation, is where is the edge, right? We used to build the edge in a fairly central manner, but you see that with this ultra low latency, and this is of course a use case, and given that we are a Finnish company, we have to have a Finnish example. You see that if you distribute the application closer to the user without distributing the edge, you actually don't achieve anything, you actually introduce bigger latency, right? So you see is that the edge itself will vary depending on the use case as well. So it's no longer something which is fairly central in a typical deployment. It is something which will be distributed much deeper into the network than we used to see, right? And in some cases, it's even such that it will be distributed up until the enterprise or up until the site where the application sits. So it can even be within the enterprise or within very close to the end consumer. Now, if you look at the typical network, and this is what the talk is all about. So typically we segment networks with, and this is mainly a service provider or an access provider type of use case. You segment the network from typically access, aggregation, core, and then you have like central data centers, which can be, let's say, localized data center or private clouds, but you can also see that some people move to public cloud type of infrastructure, so it can actually be a very heterogeneous environment. Plus you see that going forward, you see those edge clouds also appearing. So if you look there, you see that there is much more distributed clouds, and those are not like a typical data center going forward, but they are actually like very small contained type of server environments which can be deployed either on-prem or somewhere deeper into the network than we used to see, right? Now, if you then make a connotation of where the edge is, you actually see that it's spread all over the place, right? And in order to build a network which is delivering, let's say, KPIs and delivering services end-to-end with ultra-low latency, but also reliability, where you have to do diverse paths into the network in order to deliver such a service, or optimize for latency, or optimize for bandwidth, or optimize for whatever type of capability, you see that this is actually a very difficult space to deal with, right? So as such, if you look at this, in Nokia we call this Nfix, or so we build a framework around this in order to build such an environment and build, let's say, that infrastructure in a way that is supporting such a heterogeneous environment, right? So when we call this NFIX, which is standing for Network Function Interconnection, because we are dealing with interconnecting functions, either distributed or central, but also to connect them in a way that you can connect them to devices which are either physical elements, but also virtual elements, containers, or functions, right? So it doesn't really matter what it is about. It's basically we want to connect things seamlessly together, but deliver KPIs and SLAs, right? And if you look, when I change the picture from this to this, what we try to do is build these boundaries which you typically have, because if you see service providers building networks, so they typically have different teams for aggregation, different teams for core, and so on. What we try to do here is build this seamless interconnection between all of these environments in order to give that seamless connectivity between all of these different workloads, right? Because we will talk about slicing going forward, right? If you segment all of these things independently together, giving you a single API to actually connect all of these workloads together in a very distributed or very centralized way is becoming very difficult, okay? Now, how does it build? And we are not going to go to a lot of detail given we only have 45 minutes, but actually this is built all around IETF-based definitions, which are actually here, right? So first of all, the way we look at this is we use like multi-protocol BGP for a data plane. So we have either EVPN or IPVPN. So we can do both IP or layer 2 or layer 3 services. We would introduce segment routing for this, and which flavor depends on the choice of the operator. So this will work with either an MPLS flavor, either supporting over native MPLS or with IP, or with SRv6, right? So, and whatever flavor comes available to us is actually capable to be working in that framework. We use PSAP and SRT to actually make sure that we have capabilities to define SLAs and KPIs, depending on the use cases which will be supported. There is service chaining capabilities inside, which are done via the SFC working group. And then, of course, given that we want to have this programmable environment, we use all around the Yang data model, and we use telemetry to get information from the different devices in order to do like intent-based networking and closed-loop automation. So in a nutshell, before I give it to Brian, what we are trying to achieve with NFIX is building this fabric across those different boundaries, like aggregation, core, or whatever workload we see, and give you a single API. And the goal of this is to give the same experience what you get today when you go on to like a Google or an AWS or a Microsoft or Alibaba, where you basically have a set of APIs, you define your requirements for your applications, and those get instantiated into the network and give you a seamless experience using certain SLAs, KPIs, which are relevant for that particular service, right? So this is kind of giving you a bit of a space how we see NFIX and what is a key enabler going forward to build this very heterogeneous environment in the future.
All right. Thanks a lot, Wim. I'm going to take a step back now and see what we're actually trying to, or what service providers are actually trying to achieve with 5G from a business driver perspective. So one of the key things is that 5G is meant to enable a whole bunch of new revenue lines, although we'd like to focus on more the technology piece here in IETF. This is really the key focus. So when you look towards how that could be done or where those business drivers are coming from, you can look to some of these things on the slide here. So for example, there's a huge amount of promise in things such as smart cities, e-health, consumer experience with augmented reality and virtual reality, public safety applications, connected vehicles, and critical automation. And service providers ultimately want to play a role in the space because ultimately all of these spaces are being increasingly digitized. A huge proliferation of devices in each of these applications. And so this is a great market for service providers to expand into. From a pure technology perspective, ultimately we're talking about all the different IoT devices here, all the different connected devices. This can be ultimately meaning a huge amount of additional endpoints, but it's also driving additional bandwidth, and some of these have very particular latency requirements. So there's things happening in the radio network to actually support those particular SLAs. So if you use the spectrum in a certain way, use the radio access in a certain way, you can achieve low latency or higher bandwidth. But this same set of capabilities ultimately needs to be extended across the transport network to deliver the end-to-end SLAs that each of these different business drivers requires. So while in this particular presentation, we're not focusing so much on the radio access, I want to spend some time to think about how we can actually support those different and distinct SLAs across a shared transport infrastructure. Just to give one particular example there, so I mentioned a bunch of industry vertical applications. This is just one to illustrate it. Ports is a huge and increasingly complex environment. If you look forward to 2025, for example, just looking at some of our kind of lead use cases here, you see over 18 million containers going through these ports, or a given port per year. You have several 10K trucks moving around the environment. You have these environments spanning across tens of thousands of hectares, so a very large geographical space. And ultimately, they want to bring an enormous amount of technology into these ports to increase the level of automation and to increase the efficiency through these ports. So what could this mean? This is broadband connectivity for ship to shore, where actually the port to the ship, video surveillance all across the port itself, asset tracking of every individual container so we can actually see its process and its journey off of the ship through the container. You need to have low latency video feeds from key points of the site. In the future, they want to have things such as augmented reality and virtual reality based maintenance of the different aspects of the site. So they can pull in guys remotely. They don't necessarily have to drive people to every different aspect of a site. We expect to have drones flying around the site to inspect different parts of the facility. You have autonomous vehicles moving about. All of these require connectivity, and these are very high value assets. And then also there are people moving about the site, so we need to know their exact location, and we need to be able to feed all the necessary information to them. So this is just one particular example. You see there are a couple of ways that this could be deployed. It could be a private 5G environment, but service providers also look towards this as being potentially something that could be offered as a network slice or multiple network slices off of their infrastructure as well. So just one illustration here to show the kind of breadth of connectivity required to support such an application or such a use case. So when we look towards how we can actually deliver, assure these SLAs across a transport network, we look towards this kind of closed loop automation model. Inside Nokia, we refer to this as insight-driven automation. Ultimately, what is this? This is the ability for you actually to automate the instantiation of services in your network. So Wim spoke about this kind of edge-to-edge provisioning, and then the ability to have kind of network or application-based optimization. We want to have a smart IP fabric. This is really based upon having segment routing based capabilities and model-driven telemetry to be able to program and extract state from the program configuration and extract state from this environment. And then on top of that data that we're harvesting from the network, we want to be able to run data analytics. And we see this closed loop automation as being really critical because it's not just about provisioning a service in such a way that it satisfies an SLA in one moment in time. It's really about ensuring that SLA is met throughout the entire lifecycle of the service or entire lifecycle of the application. So this is a continual process that's actually running, so we can actually continue to re-optimize and react based upon the latest state of the network. So just a couple of examples of this. So Wim spoke before about the edge-to-edge connectivity. This is one particular example here. We show connectivity being created between two data center environments for 5G. So this is a connectivity between virtual RAN and virtual core. we can build this up because we can actually harvest and extract topology information from the network using things like BGP-LS. We know about endpoints within a BGP-based data center using things like BGP-LU. And from a controller perspective, we can actually pull together a topology view across each of these distinct and disparate domains. And between those two endpoints in this example, actually create a traffic engineered segment routed tunnel to enable that connectivity. So again, just that edge-to-edge provisioning and kind of tunneling within. So additionally, if there's a topology change there, we can react to that using the controller. We are doing this in such a way that's actually going to meet the different SLA constraints of the service, right? So if you want to have diversity, path diversity between these two endpoints, that's possible. Or if we move towards the next example, you want to move to something a little bit more complex. In this case, the SLA characteristic that we optimize around will be latency. So in this particular case, for example, we stay on the red path initially, but if there was something like an underlying change in the optical topology, maybe your optical transport network had a reroute, then we observe that the latency changes because we harvest that information. And in response to that, we're going to re-optimize the path from a controller perspective. So this is the type of like closed loop automation that I'm referring to, so such that we can actually continue to support these SLAs for these different services throughout their entire lifecycle. And at the outcome of this, we have this Nfix fabric that Wim described. We have a controller that's actually enabling and securing SLA-bound services on top of it, which gives us an ability to start to satisfy these network slicing requirements for each of those different applications and kind of business drivers that I mentioned at the start. And now I'm going to hand over to Reza, who's going to talk a little bit more from an API perspective in network slicing.
Thank you very much. Hello, everyone. This is a good point to go to the network slicing. So far, we discussed how we can create a network which is consumable by application. Brian mentioned what is the characteristic of that fabric, what are the use cases. And for the last portion, I'm going to tie this together with how this relates to network slicing, how it relates to us, IETF, and how basically we can use this logic to create network slicing going forward. I start with an example to make sure that at least we are on the same page. Let's say I have an operator which has transport. It has on the left side is group of tenants or customers. It has public safety, Fiat, and BMW. These are the customers. And on the right-hand side, there are a group of application servers. When we talk about end-to-end network slice, basically we are referring to logically isolated independent network from left to right. In this example, take the last, the public safety, video surveillance, CCTV. We are creating an independent network from left to the right. Each of these network slices, there are various colors. You can think of color as the SLA of that network slice. For example, for the video surveillance, most likely the SLA will be the bandwidth, 10 meg or better. For the network slice green, which is infotainment, most likely, again, for the customer BMW, for the service infotainment, the SLA is 10 meg. For the blue, autonomous driving, the SLA most likely is the latency 5 milliseconds or better. So the idea here is we are creating a group of logically independent networks from left to right. And this is very important when we talk about the context end-to-end. We are using, in this case, for example, in the left side, could be your handset, could be your IoT devices, could be your infotainment in the car, could be your gaming console. And on the right side is the application that basically serves. create each of these end-to-end network slices. Again, I go back to the last one, which is the CCTV for the customer public safety. Let's say I want to create, as an operator, I want to create this end-to-end network slice. What is needed to be done in the network from very high level? We have to create RAN slice. The meaning of the RAN slice means simply I'm going to create a context or a personality in my RAN equipment to understand blue, green, red network slice. If I go to my RAN, I will see the resources. In a practical way, it means that allocation of the radio interface, scheduling, policy, profiles, these are basically allocated for each of these colors. By the same token, if I go to my 5G core, I'm going to create a personality or context for each of these end-to-end network slices. Now I created RAM, I created core, now I have to do the connectivity between them. And here the transport slice come to the picture. Basically, transport slice is a group of connectivity with a specific SLA/SLO. And this is very important to understand the difference between this terminology. Sometimes this terminology is important to be very clear. Each of these domains has one controller. I have RAN controller, I have transport controller, core controller, and at the very top, there is an end-to-end orchestrator. As the name suggests, orchestrator is basically orchestrating a group of actions, a group of logic that should be implemented in the network. The term slice here, transport slice, or RAN slice, or core slice, sometimes it's called, for example, transport sub-slice, or transport slice subnet. All are basically exactly the same, different terminology for one thing. There are few observations from this high-level picture, which to me is very important. First, end-to-end network slice is different from transport slice. In the picture, it's very clear that a transport slice is a portion of an end-to-end context. This is the first observation. The second observation here is an end-to-end network slice, again, I pick on the last one, that dark gray end-to-end network slice can have one or more than one transport slice, meaning I can have a group of connections, and that one is more than one, so one too many. Another observation here is an end-to-end network slice depends on the application. Here we are talking about 5G, but this concept is well suited for other type of application for slicing. For example, if operator wants to share the networks, or we want to do the DC interconnect. I'm referring to 5G here as a prime example, but keep in mind that this logic, that discussion could be well suited for all other applications. So I referring to the last, another observation about the number, an end-to-end network slice can have other slices. Here when you say quote unquote other, in this picture with other I mean RAN and core. For the other application that might be different. So in a summary, an end-to-end network slice has one or many transport slices. It might have other slices. In the 5G, that other slice means RAN and core. And the important aspect here is the only context for the end-to-end is at the very top. Any other context that you see here, they are not end-to-end. I cannot expect transport to be end-to-end, RAN to be end-to-end, or core to be end-to-end. So this is basically the important aspect. If I give you an example, a practical example of how this one might work, let's say for the last video surveillance, let's say Singapore Public Safety come to Singtel and say, I want to connect all the CCTV cameras inside the city and inside devices together. It come and ask Singtel to create an end-to-end logical network for that specific application. Singtel take that request, basically goes to the RAN controller, create the context for the RAN. It should know exactly how many RAN equipment it wants because it knows how big the city is. Whether or not we should create virtual network function on the RAN or not, this is the decision that the RAN controller make at that point, also for the core, it goes, do I need to create a core? How many core I should be create? When I say core, means 5G core. Do I need to create any virtual network function for that? All decisions will be made by the core controller, and at the end, when the core and RAN are created, the transfer will be connected, and end-to-end network slice for the Singapore public safety will be created, will be exposed to that customer, and at the end, that slice can be used. The last observation in this picture is a tenant or customer can have more than one end-to-end network slice. You will see BMW has the 3 of them. It is possible to do, and these 3 for a single customer are completely independent and isolated. And this is basically the summary of this slide. From the management and control, what do we need to do? We established the fact that we need end-to-end orchestrator and various controllers. There is an orchestrator sitting at the top. Again, depends on the application. If it is not 5G, is other, that could be higher system, higher controller. But in this context, we have end-to-end orchestrator. What does it do? It does 3 things, 3 jobs: automation, monitoring, and optimization of the end-to-end network slices. These are very important aspects because in most cases, we tend to talk about only the first one. We talk about automation, how to create it, everything related to that. But at the same time, we have to be really conscious about talking about monitoring, assurance, analytic, and closed-loop optimization. So the controller or orchestrator, in this case, end-to-end network slice controller, performing these 3 jobs. At the same time, it talks to left, right, and middle controller, RAN, core, transport controller, to basically achieve the end-to-end is created for the specific network slice. The important aspect, again, here is the top level, it doesn't know that much about the detail of the network. It knows about the abstraction of the network, some level of knowledge of the network, but it really delegates all the intelligence and everything to either of those controllers. It doesn't know how RAN is created or what are the equipment in the RAN or the transport or core. It just knows that how to delegate all those components. At the same time, each of these controllers, again, doing 3 things independently: automation, monitoring, and optimization. And when it comes to us, the middle box, transport slice controller, is basically addressing the automation of the transport slices, monitoring and assurance of the transfer slices, and closed-loop optimization. And these are happening independently. And this is basically that concept of the delegation of the responsibility from orchestrator. Each of the controllers say, you do your job. If something happens, try to resolve it. To controller, transport controller, for example, it says, you create this connectivity. And it doesn't, the important aspect here is when orchestrator, let me just go to the next one, the interfaces that we have, the 3GPP on the left and right, in the middle, there is no standard defined. That interface, we have recently formed a new design team in T's working group. I'm encouraging you to go and take a look at the material that we have, the mandate and the vision that we have. That interface and everything around that transfer slice controller and everything, the logic for the receiving the request and fulfilling that request is basically will be addressed one way or another by that design team. It's recently they have the meeting and not everything is finalized, but this is, in my opinion, the right direction that we go. Coming back to that interface that I put IETF, that interface is abstract. That interface doesn't tell from orchestrator to controller, go and create a transfer slice and use RSVP for that tunnel and use L3 VPN. It says just connect endpoint 1, 2, 3, and as we mentioned, connect edge 1, 2, 3 to edge 4 and 5. My SLA is 10 meg, and I want to have a full secure network, for example. That interface is defining the connectivity this way. Transfer slice controller receives that. Except for the automation part, I have to do something, and basically for monitoring and optimization. I will talk about that in the next slide, but Long story short, in this case, we have an orchestrator sitting at the top and controllers. And I'm encouraging you to think about it. I will give the answer as we go. You might think how the hierarchical controller or whatever we do at IETF, fits here. Think about it. We will get back to the question, momentarily. But I just want to make sure that at least I started with the one question that when we finish, we have the answer for that. Now, I remove everything from this slide. I just keep the transfer slice controller and the interface on top. This is the picture that we have. If it comes, this is the picture. I have transfer slice controller in the middle. Everything else is removed from that picture. I have a higher system. Again, I try to be generalizing the concept. I have a higher system. In 5G, we call it end-to-end network slice orchestrator. The higher system sends a request, number one, to create the connectivity. Again, connectivity in this context means connect edge 1, 2, 3 to edge 4 and 5 with SLO 10 meg or better. Again, this is the second question. That interface should not only have this information, but some information about the request which is coming. For example, in the previous example for the Singapore Public Safety as a customer, that interface one has information about who is the customer, what is the service is CCTV, customer is Singapore Public Safety, and some other information about that end-to-end network slice. This is the second question. We don't really need this information for automation. Why we need that one? I try to get back to it at the very end. So, number one, we receive the request. The transfer slice controller intelligently is going to realize that one in the network. And this is basically the whole idea of connecting this discussion to whatever Wim and Brian mentioned 10 minutes ago. We receive the request. We are going to realize it in the network. Realization means depends on the network that I have. If it is microwave or PON or optic or IP, the way that I'm creating this or I'm realizing this connectivity, that transfer slice, it's different. But at the very end, number one doesn't change if I implement this connectivity on top of microwave or PON. Number one is do the connectivity between edge 1, edge 2, edge 3 to edge 4 and 5. So number two, basically tie together the concept that we discussed so far with mapping the request to any service, tunnel path. Nfix will be one of those that we can use. And basically, number three, we realize that one in the network, depends how we want to do it. We are using that network as the consumable resource, and we are using the API to create the connectivity. I asked you two questions. The first question was why we need some other information when I want to create a number one. It should have, in addition to endpoints and SLA and SLO, it should have some other information. The answer to that one is number 4. In addition to creation or automation, we need to do the assurance. We need to do the monitoring and closed loop. For those, we need to have some information that how this transfer slice basically connect to the end-to-end network slice, which customer is requesting for that. From that aspect, using this information basically helping us to do the assurance and the monitoring and optimization of the transfer slices. If I recap whatever we put here, we have at the bottom, we have a consumable network resource. Now the application that we build on top basically is going to use that resources. And basically this is the way that we see the IETF can fit here. Number 3 is exactly whatever IETF has lots of the history on that. And doing number 1 and 2 and number 4 is basically leveraging everything that is already here. And another question that might be relevant here sometimes, there's some question of how we do for example, soft slicing versus hard slicing, how we can make sure the resources is in the network. All is related to number 3, the realization. Do we need any specific new protocol or technology to achieve number 3? At this point, most likely the answer is no. But as we go forward, this is basically one of the items that we can think and we can address going forward. So this is end of the presentation for us. I give the stage to Wim to basically wrap it up, and we have, I guess, 10, 15 minutes to go through question and answer. Thank you very much.
Yeah, to conclude, yeah, basically, I think you try to see a little bit how we as Nokia see this world and how networks need to be built, or what are the different capabilities we need to have in order to support like 5G type of use cases. So Nfix, in our view, is a key building block, or is a key enabler to actually give you that ubiquitous connectivity between all of these heterogeneous workloads which we actually have to deal with, right? And it actually spans connectivity across core, access, distributed things, because what we are trying to do is build a kind of a fabric to make that consumption very easy, right? And do that in a way that we achieve that where you can deliver actually SLAs and KPIs. And sometimes I refer to Nfix as kind of what SD-WAN tries to do. For those people familiar with SD-WAN, it's trying to do this ubiquitous over the internet, over the overlay, under any transport. What we are trying to do here is what, if you own an infrastructure and you want to build certain KPIs and deliver ubiquitous services across those heterogeneous environments, that is what we are trying to achieve with Nfix, right? The third bullet which I'm saying is that it's built on all IETF standards which are actually happening here. The challenge which we have sometimes, it's actually people don't really know which pieces fit together, right? So we decided that we are going to write a draft. It will be an informational draft. So if people are interested in contributing, I would welcome them. So please contact us after this talk or something like that. Because I think it's important that it's sometimes important that we fit the pieces together, because we are using many building blocks which are built here, right? So we're using things from BAS, we are using things from Spring, we're using things from NetMod, we're doing all the Yang definition models which are delivered or being built in different working groups need to be consumed together. So we use PSAP, so there is different components from different working groups which we are leveraging in order to build this framework, right? But none of this is actually very proprietary or very standard, so it works with multi-vendor. And actually we have implementations today in live customers where we are actually doing this using those building blocks. And then the second bullet which is here is that in order to deliver this whole environment, we need to come to a framework where the networks are consumable through an API, is how I say it, right? And I always make the reflection towards what the public cloud guys are doing today. If you see how easy it is consumable, their networks is consumable, this is where we should go towards, right? So we should basically, with a few point and clicks, be able to instantiate those capabilities which are your customers demanding, and doing that in a seamless way over that heterogeneous environment. And this is kind of how we see the implications of 5G and how networks should be built, or the capabilities that should be delivered going forward to achieve and to deliver those type of use cases. With that, I think we are almost on time, and I don't know whether we have time for questions or not, but we are happy to have some questions if there are some in the room. But I don't know how it will work because we don't have mics.
Yeah, there is. There is mic if there is question.
Are there any questions or?
Maybe it was either very clear or not.
Hello, Kirsty P, NCSC. So my question is about the join-up between your use cases and what you're sort of needing from this community, and how do you get a full range of telco operator requirements into this community, and do you think that the join-up is currently working?
So the question is about how we get requirements from operators in this community. So what we do from a Nokia point of view is all the different requirements we get from operators. We try to, so that's how we contribute to drafts in IETF. So if we see that there are certain missing pieces, like Reza mentioned, For transport slicing, we believe there is a missing piece for a service abstraction to give you that slice and transport slice controller. We build a contribution into the various working group in order to contribute and make sure that we build this open framework to support these type of things. So basically the requirements which we see from customers, we bring back to IETF, and we try to contribute and try to make those things adoptable or change depending on the use or how IETF sees this, adopt based on the feedback of the working group here. Okay?
I saw on the slide about how these slices let you do more than one thing at the same time on the network, or different companies like Fiat and BMW could both use the same network. And what I'm struck by is already when I'm at home, I can watch Netflix while at the same time my Tesla's doing a firmware update because I have an internet connection. I didn't see any mention of the internet in this presentation. Is this a totally new thing to replace the internet?
No. So this is actually, okay, so this is a good question. Actually, if the internet is good enough for that service, we use the internet as so we use basically the internet connectivity, right? So it's only when you have specific requirements which cannot be met or which are like certain latency requirements and stuff like that, and your service delivered on X, Y, or Z, you actually do or change things. So you have the capability to influence based on your needs of that specific use case. But if the internet is good enough, there will be internet connectivity used for that particular service.
So in your end-to-end one of the slides, you showed the RAN slice and the transport slice and the core slice.
Yes.
Then you said essentially the leftmost, the either ends are mostly from 3GPP. 3GPP does the RAN slice and maybe on the core side. Then the transport slice, you said IETF can standardize that. What exactly IETF can standardize? Is it just the provisioning of the slice, or what is the standardization that is left here?
Whatever we plan to do at IETF, I encourage you to take a look at the outcome and the result that we have on the TIS going group for the network slicing. In the summary is we want to, first of all, define transfer slice. What is the consensus, the definition of that, how it relates to network slice. This is the first thing. The second one is study a framework to make sure that we know all the components that we have to do, whether or not there should be, for example, a new NBI to be built. This could be one of the outcome of that discussion. And last but not least, to address the mapping that I mentioned. If I want to map that abstract interface to a specific technology, we are going to have a few use cases, and we basically they show how the mapping might work in the real world. So these are the three most important aspects that we want to cover there. As we go forward, definitely we need the contribution from everybody, and whether or not there are some other things needed to be done, this is for the future. But at this time, we wanted to make sure we are really focused on a couple of things. We are not basically boiling the ocean. At the same time, how relevant that work is to IETF is a prime the example of whatever we do, and it's very important to consider that.
Mm-hmm. Maybe a follow-up question. So when you create a transport slice, what are the parameters that, let's say, 5G system will give it to the transport? So let's say URLLC, what will be the parameters? I'm just curious.
At the high level, again, this is something I don't want to say something that we haven't decided in the design team, but as a general concept, the input that you receive here, I want to connect edge 1, 2, 3 to edge 4 and 5, so a group of edge that should be connected. The SLA and SLO for that connectivity is what is the objective that we want to reach, is the latency, reliability, security, and so on and so forth, and some other data, which is the use case dependent. In the 5G, for example, I mentioned some other information that helps us not only for automation, but for the other assurance and other aspect is how this relates to the end-to-end network slice. Which customer is asking it? What services is there? So these are very high level. The detail of that, obviously, we have to go through it to make sure that we are addressing it in a very logical way, and whether or not we need to add other attribute to this or remove it, this is we have to go through the process.
Okay, thank you.
Okay, no problem.
Okay, this is Paul Zhang from SKKU. So a very nice talk. I have one question, one comment. So you propose intent-based networking will be useful for network slicing. Is that correct?
Yes.
So basically, you can see high level, some policy, service level will be translated into network level or device level, right? So I believe one of the core functions is translation. So are you considering how to translate service level policy into low level policy? Are you considering or are you working for that?
What is your question? How do you translate policy from between different devices, or?
So which means the high level, service level agreement, right? Kind of a service level policy I can define.
If you look what Reza was talking about, actually is an abstracted view, right? What you typically see today, unfortunately, we did a lot of work in IETF with respect to data model standardization and stuff like that. What you do see is that the vendors have not all implemented that uniformly yet, right? So what you need to do is basically, even if we say about intent-based networking, what you typically still see is that you need a device model which is specific for a specific vendor. So as such, what we are doing is we have like these abstract service models which are being defined. Like, for example, even in IETF, you have L2SM, L3SM being defined, right, as a service model. But what you see is if you have to implement that to the specific device, you sometimes need a translation layer. So we have like device abstraction capabilities, which are actually mediating towards a specific device implementing that particular use case in order to translate for the specific models which that device actually has implemented. But so we have this, there is an abstract service layer, and then there is a device type of model which is actually then implemented into the device, depending on the capabilities that device has enabled.
And then maybe, Wim, just to add, I mean, that actually only needs to exist on the edge itself, as we mentioned there. Correct. So beyond that, everything in between is about how you can assure the abstract SLA that gets translated into something meaningful for the network, how you can ensure that in a closed loop automation manner. Yeah,
basically the IETF developed many young data models, high level and low level. The problem is the link to each other. The translation is missing right now, so many people currently working for that. So basically, the I2NSF network security function working group, I am one of a member. So we basically implemented the policy translator to link high-level policy into low-level. So I believe network slicing case, I think we can leverage previous our work.
No, I mean, if there are missing pieces which you believe need standardization, I think we are happy to talk and then see how we can make that happen.
Okay. The other question is some collaboration with the other standard body. For example, the I2NSF, we are facing the problem is we are using security network security function with the SDN. For example, the problem is IETF, I2NSF, and the SDN. The interface should be specified. The problem is how to collaborate with other standard bodies. So your case, 3GPP LAN area, some standardization, and IETF, some, the standardization has something collaborated, right? So that is my question, how to collaborate.
I will give you a short answer since we are almost
we're probably running out of time here, but we can take this offline to see what needs to happen beyond this.
Okay, thank you.
Talk offline. Thank you very much, everyone.
We have to stop? Okay, sorry.